Hello everybody, welcome back to my channel, and today we'll be doing a very simple experiment called electrolysis of salt solution. And the salt that we'll be using today is your sodium chloride or table salt, NaCl. And next I've prepared water, and as you can see I don't have lab equipment, so instead of using beaker I use a random bottle instead. And this thing is crazy because it's 600 cm3. And it's crazy, just bear with me. Next is that I've prepared two pencils that is sharp at the end, and this thing to hold it later. Okay, and most important thing is your battery. You know, electrolytic cell battery is very important. And right at the end of the video, I prepared my own drawing, my own observation, the observation and also explanation. So without further ado, we'll start the experiment right now. Let's go. Okay, so right now I'll be putting your NaCl into the water, and then it will become salt solution. And then I'll put until it is concentrated. That means I'll put a lot of it, many of it. Oops. Okay, is it considered as concentrated? I think I need to stir it for a while. Okay, I'm stirring it. There's no heat or anything, just pure stirring. Okay, it's dissolving. And also salt solution is actually electrolyte, so we can conduct electricity. You know, we always write in exam, the presence of free moving ions can carry electrical charge. There it is. Okay, I'll put it in right now. Ta-da! And we'll start the experiment right now. Oh shit. Okay, wait. So this is positive terminal, which is your anode. In electrolytic cell, your anode will be positive and your cathode will be negative. So this is the positive terminal, means this is your anode. The negative terminal means this is your cathode. So anode, cathode. Can you see it? Okay, I'll just connect it like this. Oh yes, I saw it. Nice. Okay guys, can you see the bubbles? Can you see the bubble? Can you see the bubble? I'm afraid you can't see. Can you see the bubble? There's bubble right at your cathode. Here is negative, so it's cathode, and here is anode. Cathode is negatively charged, anode is positively charged. Because sodium chloride is concentrated, right? So my negative terminal, which means my cathode, will be releasing hydrogen, and my anode, positive terminal, will be releasing chlorine instead of oxygen. Because it is concentrated, so it will be releasing chlorine gas. And I know it's kind of dangerous, but so far I'm wearing mask and nothing happened. So here we'll be releasing hydrogen gas, and here we'll be releasing your chlorine gas. And can I do it like this? Okay, let me try. But it's kind of near. I don't want the chlorine gas. I don't want to smell the chlorine gas, guys. Okay, wait. Alright. Oh shit, you cannot see. Alright, like this. You see the bubble, right? Over here, this is your hydrogen gas. And here is your chlorine gas, which nobody wants to smell it. Okay. And yeah, I won't smell the chlorine gas. You know, chlorine gas will damage your lung, and it's not a good smell though. It's not like ester pleasant smell. Come on, chlorine. It is an irritating odor, and what else? It's pungent. It's a pungent smell. So it will damage your lungs. Not good. Don't do that in school. And right now, without further ado, we'll start our explanation right now. Ta-da! Let's go. Okay, so what happened here is actually like this. So first of all, we have to know that this is an electrolytic cell, and an electrolytic cell will have battery. And when you have battery, your anode will be positive and your cathode will be negative. So in this case, through the battery, you will find out that which terminal is positive. Obviously, a longer one is positive, the shorter one is negative. So the longer one, when it is positive, it will be anode. The shorter one, which is negative terminal, it will be cathode. And next, after we find out the positive and negative terminal, we will find out what ion that will go to the carbon, your pencil. And we'll be using pencil. As you know, pencil have carbon, and carbon in this case will be our electrode. And first we have to know what ion will be flowing to each carbon, so with each electron. So in this case, as you can see, if it's positive terminal, it will attract negative ion, and negative terminal will attract positive ion. So let's find out our positive and negative ions. So in this solution, we have what? We have salt solution. The salt is NaCl and solution. Solution here, oh, can you see it? Solution here is your keyword because solution means you have H plus ion and OH ion, OH minus ion. So you have H plus ion and OH minus ions because of solutions, and you have sodium chloride, sodium as positive charge cation, chloride as anion. So you have 2 positive charge ion and 2 negative charge ions. In this case, it will go to their respective terminal. So in this case, positive terminal will attract negative ion. So how many negative ions do you have? You have chlorine and you have hydroxide. So both of these will come over here. And both of these positive will go to the negative terminal. So this is why I write it here. Next, so now you need to find out that which one will be selectively discharged. So in this case, we'll talk about the cathode first. So cathode, because it is negative terminal, so you need to find a more electropositive substance here. So in this case, obviously hydrogen is more electropositive than sodium. This is why hydrogen is selectively discharged here, and hydrogen is reacting here, producing hydrogen gas. This is all according to your ECS table, your electrochemical series table. You need to find out which one is more electropositive and more electronegative through the table. And when hydrogen gas is released here, the test to test whether it has the presence of hydrogen gas is by using the burning wooden splinter. If you place the burning wooden splinter around this area and produce a pop sound, that means there's presence of hydrogen gas. And next, we'll go to your positive terminal. So negative ions will attract to positive terminal, right? So your negative ions are chloride and also your hydroxide. So here, in this case, actually, here is positive terminal, and by right here, we'll be choosing a more electronegative substance, right? But in this case, because it is concentrated, because my sodium chloride is concentrated, so I'll be using chloride ion instead. So chloride ion is selectively discharged. That's why instead of OH, it will be Cl minus. So obviously Cl minus, the equation is like this. Ta-da! Okay, so Cl minus will lose 2 electrons and become Cl2. So the gas produced here will be a chlorine gas. Okay, but let's say that just now I'm not using concentrated sodium chloride. That means I'll be using hydroxide ion instead. Why? Because this is positive terminal, right? So we'll be using a more electronegative substance. So if we were to compare two of these, which one is more electronegative? Obviously, is your hydroxide ion, right? And now we want the one that is less electropositive, which is more electronegative, right? So obviously we'll be choosing this. But right now, because it's concentrated, so without further thinking, we just choose chlorine. When something is concentrated, we'll either choose Cl minus or Br minus or I minus. When it is concentrated means it is 1.0 mole per dm cube. So yes, this is it. And yeah, this is the arrangement in the ECS table, and I forgot to show. Yes, this is it. So if it is OH, it will form oxygen gas over here. In this case, a test that can test presence of oxygen gas is your glowing wooden splinter. If there's presence of oxygen gas, your glowing wooden splinter will rekindle or relighted. Okay, so that's all for the video. I hope you understand, and see you next time. Sayonara, bye bye.